Hey guys, so this is telling you that you have the graph of the continuous function g. Now read this carefully. It says the graph of the continuous function g, comma, the derivative of the function f is shown above. So what is that equivalent to? And hopefully you are saying f prime. Okay, because it says the graph of the continuous function g, which is also the derivative of the function f. Okay, so then let's look at the first part. Part A gives you f of 1 is 3, so that's like an initial condition. And they want the value of f of negative 5. Well, let's start with, we know at f of 1, we are at 3. And then, because they want us to determine what f of negative 5 is, and we have the graph of f prime, how do we get f out of f prime? What do we have to do? And we would have to take its integral, right? Which is going to be the area under the curve. So we start with that initial condition of 3, and then we're going to add to it, and we are going to integrate f prime. Okay, now let's talk about these bounds. So remember, I think we had another question similar to this one. So when they give you an initial condition, its value is 3, and that's why we have a 3 here. So this x value, though, that corresponds with that, is a 1. So that is going to be our lower bound, always, of our integral. So we're going to put a 1 there. So let me just kind of backtrack for a second. If this said like f of 2 equals 3, we'd still have a 3 here, but we would have a 2 here. If this was a negative 5 in here, we would have a negative 5 there. Okay? All right, so then what goes in this top bound should always be whatever value they're asking us to evaluate it at. So that's going to be negative 5. Okay, so now we're just going to work this out. So we have 3. Now, hopefully you notice something here. So we have an integral. The bounds are off, so I'm going to switch and negate. So that's going to be negative 5 in the bottom and 1 on the top. Okay, so now all I'm going to do is I'm going to find the area under the curve, and I'm going to go from negative 5 all the way up to 1. So I am going to find the area of this space in here, which is a trapezoid. Now you could do a rectangle, or actually that might just be a square, and a triangle if you so choose, but I'm going to do trapezoid. Now there is no area right here from negative 1 to 0. And then lastly, I'm going to go all the way up to 1, so I'm going to do that little triangle right in there. So you're basically taking the area of those two spaces. Now just be a little careful. What do we know about this space right here, though? Okay, do you see that that's going to be a negative area because it's underneath the x-axis? So we're going to do the area of a trapezoid, which is 1/2 height, base 1 plus base 2. I am going to negate because, remember, the area is underneath the x-axis. That's why that 1/2 is negative. The height of that is 3. And the two bases are 3 and 4. Okay, so there's the trapezoid. Plus, now the area of the triangle, now the triangle is above the x-axis, so we're good to go there, so we can keep that positive. 1/2 of 1 times 2. Okay. All right, so what I want you to do is I want you to pause me and figure out how much that is. All right, so I have 3, and then I have plus. The trapezoid was 21 over 2 minus the triangle's area, which was 1. Okay, so that's going to be, what do we have over here? Well, that's going to be 2 plus 21 over 2, right? So I'm going to make that 4 over 2. Plus 21 over 2. Final answer, 25 over 2. All right, so they're asking us to evaluate this integral right here. Now, this is the graph of g, and they want the integral of that. So isn't that the area under the curve, just like what we did on part A? We don't have an initial condition, but I want to just take a moment and let's look at the graph from 1 to 6. Because look here, we start at 1, and actually let me just, we start here at 1, and then we go to 6, but here's the problem. I'm going to just cut this off at 3. Do you see from 1 to 3, it's that space right there, that square, okay? But then what happens is, after we get to 3, look at what happens. The space underneath is not anything that we have an exact formula for, so we actually have to do the integral, okay? And if you look, we actually have a formula that we can do the integral for, okay? So we're going to find the area under the curve here just by doing base times height. But the area from 3 all the way to 6 is not like a square or a triangle, so we have to use the actual equation for g of x and integrate that. Okay? All right, so then what I'm going to do is I'm going to split this integral up. So I'm going to split that up into the integral from 1 to 3 of g of x dx. And then I'm going to split it up from 3 to 6 of g of x dx. Okay, I can't fit, yeah, I could squeeze it in there, dx. Okay, so 1 to 3. I'm going to just bring it down over here. So 1 to 3, that's a square. The base is 2, the height is 2, so I know that the area of that space is going to be 4 plus. All right, so we are going to integrate from 3 to 6 the g of x equation, which is 2 parentheses x minus 4, that quantity squared. Okay, so now let's remember I have a quantity and that's squared. So what am I going to have to do here to integrate? Use substitution. So our u would be x minus 4, and then our du would be 1 dx. All right, so if you look at this, my du is 1 dx, and I have 2 dx, so be careful. So what do I need to multiply this 2 by for it to say 1? So you're going to need a 1/2 on the inside and then a 2 on the outside. And what's the other thing that we also need to do when we're doing u substitution and we have bounds? Do you remember these bounds? Go right in there so we can write new ones. All right, so let me continue this. So this is going to be 4 plus, now we have 2, and we have the integral from, all right, let's do the top bound first. So the top bound, if we plug that in, we would get 2. And in the bottom, for the bottom bound, if we plug 3 in, we would get -1, right? And then that's going to be u squared du. All right, so let's keep going. So that's going to be 4 plus 2. And then that's going to be 1/3 u to the 3rd, and we're going to evaluate this from -1 to 2. Okay, I am going to go like this, and I'm going to combine those guys right there. Okay, so that's going to be 4 plus, and that's going to be 2/3. All right, so let's plug in the top bound. So 2 to the 3rd is 8 minus -1 to the 3rd, which is -1. All right, I'm going to bring that up over here. So that's going to be 4 plus 2/3. And 8 minus -1 is 9. So that is going to be, what do we got there? So 9, 18, so that's going to be 6, right? So 4 plus 6, which is 10. And there's your final answer. All right, so part C is asking for the graph of f. When would that graph of f be increasing, and concave up? Well, if we're talking about f, when would something be increasing? What would we be looking at? Okay, so wouldn't we be looking at f prime? And then if we were talking about concave up, what would we be looking at? We'd be looking at f double prime. All right, now remember from part A that this is the graph of f prime. So what do you think? I'm thinking the best thing we probably should do is just do a sign chart. So I want f prime, and I have f prime. So when I do a sign chart, I should be looking for above and below. All right, so let's start with that. So I've got f prime. All right, so I notice that my graph initially is below the x-axis until I get to -1. So until I get to -1, I'm below the x-axis. All right, now this is something that we really haven't seen before. Right here, from -1 to 0, this isn't anything. Okay, so we've not ever come across this. Obviously, it was on the 2018 AP exam, but even they said, oh, we haven't seen something like this in a while. But that's not above the x-axis or below the x-axis. So you can either leave it blank, or sometimes I'll just write 0 because it's not doing anything. Okay, and then let's look at what's happening after. You can see that the graph after x equals 0 is above the x-axis. All right, let's do the same thing with f double prime. All right, so we have a graph of f prime, and we want a sign chart for f double prime. So we should be looking for increasing, decreasing. Okay, so this graph, if you look at it, it starts out not doing anything here. That's not increasing, and that's not decreasing. But once I get to -2 to -1, do you see I am increasing? And then I have the same issue here. It's not doing anything again. Okay, but not a big deal. So we can handle this the way we handled it on the last one. So up till -2, it's really not doing anything, right? All right, from -2 to -1, we are increasing. But then from -1 to 0, we're not doing anything. So I'm just going to stick in a 0 there. Then from 0 to 1, do you see I'm increasing? Then from 1 to 3, I'm back to doing nothing again. Okay, I'm going to just put a Z there because I'm running out of room, I'm sorry. Then if you look from 3 to 4, I'm decreasing. And then from 4 to 6, I am increasing. So I'll stick a little plus sign in there. Okay? All right, so now let's reread the question. So it's saying, on what open intervals from -5 to 6, if any, is the graph increasing and concave up? So we want increasing and concave up at the same exact time. All right, so let's look at the first derivative here. Well, it's increasing any time after 0, right? Because nothing's happening over here that's increasing. So we're looking from 0 on. So I'm just going to basically look from 0 on over here and see where I have a positive. Well, look, I have from 0 to 1, and I have it again from 4 to 6. So those would be my two intervals. So 0 to 1, or also 4 to 6. And your reason would be because f prime and f double prime are positive during these intervals. Okay, so it asks for points of inflection. So points of inflection, you should be thinking second derivative, right? So that would be f double prime. Well, we have a second derivative sign chart in part C, and this was that sign chart. All right, so basically we are looking for points of inflection, and remember, when you have a point of inflection, your second derivative is going to change signs. Well, we don't have any sign change here because this is 0. The same thing here, the same thing here, the same thing here, and the same thing here. So the only value where you do have a sign change would be at x equals 4. Okay, so then your answer simply would be x equals 4, because f double prime changes sign. About this point. Okay, so about this point.